All right, what's the solution to the system? Use substitution. Um, Basically, we're going to solve for one variable, and actually, if you look at these equations, you can see that this second equation is already solved for y. It says y equals. It doesn't have a coefficient other than 1, and it doesn't have some other numbers. It just says y equals. Okay? You can either have y equals or have x equals, either way, and then you just substitute that variable in, substitute the expression on the other side of the equal sign for that variable. So since it says y equals on that equation, I'm going to take the first equation that says 3y equals negative 1/2 x plus 2, and I'm going to substitute for y what the expression says y is equal to. Negative 1/2 x plus 2. And the equation, the expression says y is equal to negative x plus 9. So when I distribute that 3 through, I get negative 3x plus 27. Hi, Louie. It's my kitty, Louie. Equals negative 1/2 x plus 2. Okay? Now I'm going to get all of the variables to one side, all the x's to one side, and I'm going to get all the constants to the other side. And since I like to deal with positive variables, doesn't really make a difference, but I'm going to add this 3x to both sides, this 3x. Okay? When I do that, I get 27 over here, and on this side, 3x minus half an x gives us 2.5 x's. And then we have the plus 2. So we say minus 2, and we get 25 equals 2.5x. You can also write it as 2.5x, and I'm going to do that just so that you can see what happens next, which is we're going to divide both sides by 2.5 because that's the coefficient on the variable. Okay? And I'll have to write it over here on the side, but it's just a fun fact that when you divide 25 by 2.5, you get 10. Okay? So we have as a partial solution, x is equal to 10. Okay? We still need to solve for the other variable. So we can take one of the equations. I'm going to take, hi Lou, kitty walking on the desk. I'm going to take the y equals negative x plus 9 equation. It's just a simpler equation, doesn't have a fraction in it. And I'm going to write what x is equal to in there. It says x is equal to 10. And then then if we solve this out, we get y equals negative 10 plus 9 is negative 1. And that then suggests that we have, as a point, as a solution for this, x is 10, y is negative 1, writing it up on top in case you don't see what I'm writing. And, sorry about that, just trying to neaten it up a little. We believe that that's what the solution is. Well, if that's the solution, then what I should do is I should take the second equation that I plugged these values into, well, I plugged the 10 into the y equals negative x plus 9. So I'm going to take the other equation that we have, which is 3y equals negative 1/2 x plus 2, and I'm going to substitute in the values of the variable that we got and see if it does work out to be a true statement. Okay? So I'm going to plug in 10 for x, negative 1 for y. Oh, silly me. Be careful. Don't make that mistake. I plugged in 10 for y, not 10 for x. If you do that, clearly you can see that 30 doesn't equal like 2.5, right? That's my mistake because I didn't put it in the right place. So be careful about that. It's got to go right in where it's supposed to go. Y is equal to negative 1, and x is equal to 10, like that. Much better. Now, 3 times -1, -3. Okay, 1/2 of 10 is 5, so -1/2 of 10 is -5. And plus the 2. And then -5 plus 2 is -3. It checks out. So we then, up on top, where you can see, have as our solution 10 comma -1, and that is C. Okay? Substitution. Now let's do this again, and there's only one slight modification to this, which is in number 22, we don't have one of the equations already solved for the variable. Now we could solve either one, but you might be able to just see straight away that if we took x minus y equals -6, all we have to do is add y to both sides here, and then we've got just x equals. It's already solved, right? The other equation, we'd have to move things to the other side. We'd have to then divide. It's a little bit messier. Okay? So when we solve for that, we've got that. And so we're going to use this equation when we substitute it in for the other, for the other equation. So I'm going to take 6x minus 3y equals -9. And where I see x, I'm going to put in what x is equal to. Okay? And notice that I've written the rest of the equation exactly the same. X is equal to y minus 6, so that's where I put y minus 6 where I had x. Now distributing this through, I get 6y minus 36 minus 3y equals -9. Remember, the whole goal here is to get this equation down to a single variable, because the original equation right here has two variables, x and y, and that only represents one of the lines, and that means that there's an infinite number of points along that line that could be the x and y that solve it. So there's no way to nail it down to one single x and y. Okay, but once we substitute in the second equation into that, the y minus 6 in for the x, what we're doing is we're combining both equations together, and once we combine them both together, there is then only one point that solves them both. So by doing substitution, you're basically saying we're putting both of these equations together, and now we're only going to have one x and y value that works. And in fact, the start of it is to see that the x's went away, and all we have now are the y's. So when we combine the y's, 6y minus 3y is 3y minus 36 equals -9. And then we add 36 to both sides. We get 3y equals 27. I'm going to write that up here, up on the top. I'm going to just box this out a little bit further, okay? And write again what we had at the end, 3y equals 27. If you ever have to go to a second page or a second column when you're solving equations, take what you have as the final line on the first column or the first page and rewrite it again at the top. Okay, now we take 3y divided by 3 equals 27 divided by 3, and we get y equals 9. And this is a partial solution to this, that y is equal to 9. You can see that it's suggesting that it's probably b, because b has 9 for y. But now we need to plug it back in and see what we get for x, and then test it out. Now, what we want to do is take one of the equations. I'm going to take the simpler of the equations, which is x minus y equals -6. And I'm going to substitute into that the value that we came up with for y, which is 9. Okay, so we say then x minus parentheses equals -6. And what was that value? That was 9. Okay, so then we got x minus 9, And I'll just write it without the parentheses. You don't really need to do that, but why not? Okay, and then we need to add 9 to both sides in order to solve for what x is. And we find that x is equal to 3 according to what we came up with here. Okay? And so, again, that does indicate that the answer is B. But before I select B as the answer, I want to verify that the answer is correct. So how am I going to do that? I'm going to take the other equation, not the x minus y equals -6, which is what I just used here to find x. I'm going to use the other one, which is 6x minus 3y equals -9. And I'm writing small, sorry, because I'm a little bit short on space and I'm running into the controls that I have here. Equals -9. Okay, so sorry about the way that it's all smashed in, but what are our values? Well, we've got, as a point, we've got x is equal to 3 and y is equal to 9. So then when we simplify those, 6 times 3 is 18, minus 27, 9 times 3 is 27, equals -9. And 18 minus 27 is -9. And that checks out. So that means then we have, as a solution, we have x is 3, y is 9, 3 comma 9, and that is B. So for this one, the only thing that was different from the first one, 21, is that you had to solve for one of the variables instead of already having an equation with the variable isolated. But not that big of a deal. You should, at this point, be comfortable manipulating equations, adding, subtracting, dividing things, knowing what to do. By the end of Algebra 1, this is a skill you must have. So if you find yourself still not having this skill, well, I would suggest that even if you get a passing grade for Algebra 1, that you try and work on this a little bit, because if you go into your subsequent courses without this skill, you're going to struggle, because this is a skill that everybody needs you to have now. All your courses need you to have it. So hope you got it.